point when I was at GSMA and I first met CCgroup, and Paul used to follow me around, and every time I said connections, he'd say no subscriptions, or vice versa. We were talking about 4G at that point. We were talking about the balance between 3.5G and 4G, why 4G was different, why 3.5G was current, offsetting WiMAX. So to now be talking about 5G and at the point where people are actively talking about 5G launches it's a long process. The interesting thing that's different is some of what I'm going to talk about. So with the progression from 2G to 3G to 4G, there was technology as a discontinuity. There was also very specific service changes. And I think what's happened with the step from 4G towards 5G is that 5G has tried to start from a different point. The net result of that is also that at each point through the generational transitions, the level of marketing and hype has got bigger, the level of technical differentiation has got smaller, and now we are at, with no disrespect to anybody in the room, we are at peak hype as a result of an awful lot of marketing and an awful lot of PR from an awful lot of vendors and operators as well. So I kind of have this dual role now. I have my Samsung hat on to a certain extent, and I have to talk about Samsung products on occasions. You're not going to get any product pitch today. And then every now and then I'm allowed to take my hat off and throw it in the corner and go, yeah, but it's all hype and it's all rubbish. And what you're actually going to get today is kind of where we start from in terms of where 5G was incepted, and then work through what's going on technologically, but also what's going on from the perspective of business and strategy as well, amongst operators and vendors in general. So I'm going to run through these slides. I'll take some questions at the end, unless you have anything that's really burning, or I say something really stupid, in which case, by all means, leap in. So let's make a start. And the start is the starting point. So right at the very beginning of 5G, the NGMN wrote a white paper which they launched in 2015. This was already starting to happen. There's probably 2 years of discussion of 5G before NGMN wrote this paper. GSMA also wrote a paper in December 2014. When I say GSMA, I wrote a paper in December 2014, which I floated under the nose of the GSMA board and managed to get out with a logo on it, which doesn't say anything near as positive as this. It's a lot more strategic, it's a lot more business oriented, it's a lot more pointing out that a lot of what's happening in 5G at that time was being driven by, if you like, just very narrow thinking in terms of, we've done all of this for each generation previously, and so it's about 10 years and we ought to do some more. We ought to have another step change in data rate, we ought to have another step change downwards in latency, and as a result, an awful lot of stuff was beginning to appear. That's all right, off you go. I won't take offence, but I know all of you. Right. So what NGMN did instead was, rather than taking a technological approach to a differentiation between 2G and 3G and 4G, they started to say it's actually much more about use cases. And so we need to look at what the problems are from the perspective of customers, and work backwards from that. So this illustration here, this is the table of contents in the NGMN white paper. You've got an executive summary and introduction, and then immediately in the 5G vision is business context. That didn't happen in any previous generation. The previous generations were always driven by technology. They were generally driven out of 3GPP or ITU, and they started off with a bunch of technology which would deliver step changes, and then people started to think about what they could use that technology for. With 5G, they tried to start off with something which was much more around use cases, and then drive requirements back out of that. So this is a slide which NGMN used, and it's within the paper as well. So they were looking at pervasive video, because by this stage we knew that video was already 60%, 70% of the traffic in most mobile networks, particularly in developed markets. And so the extension of video, both in terms of the number of people using it, the amount that they used it, higher definition graphics. The expectation was that there would be much higher demands on bandwidth from the perspective of bandwidth in a moment in time, but also the duration of usage of that bandwidth as well. Broadband access everywhere, 50 megabits per second everywhere was a target. That's quite a difficult thing to achieve for a number of reasons. One is when you get to the edge of a cell in a mobile network, things get very bad. You have two cells trying to talk at the same time, they interfere with each other. You have handover between cells, at which point everything goes horribly wrong on the amount of traffic that can be received. And then you've got places where there's just no coverage, like in fields or on the train line from Staines to London. So then you need a high-speed train and higher user mobility. There's a whole bunch of stuff happening around that now, but that was already identified as a use case. Internet of Things, we know all about that, right? And sensor networks. Tactile internet, which kind of goes beyond that. So some of the things around haptics, the idea that rather than just seeing and hearing things, you would be able to feel them, and all of that would be conveyed via a mobile network as well. Lifeline communication, so in situations of natural disaster, when the network vanishes, how you bring a network up quickly so that you can reuse it. Ultra reliable communications, which is essentially networks which are always there. So if you think about things like, at this point people were talking about things like connected pacemakers. You don't want a pacemaker going offline. You can't turn it off and on again at times of bad things. You need it there. And also in 2015 people were really expecting autonomous cars to be perpetually connected and there to be some interdependency. And then broadcast-like services, this has kind of been on the agenda for about 30 years, never mind in this generation, but broadcast as well. So that was where everything started. And that was to address a whole bunch of key scenarios. So that started to fall into a bunch of use cases which are a bit kind of broader and a bit fluffier and a bit more all-encompassing. So essentially 4 categories: mission critical services, which is all of that emergency services network, ultra reliable, things which are dependent upon high availability and high coverage. Massive IoT, so moving into the 50 billion. I saw today Huawei are talking about 100 billion devices by 2025 now connected. Fixed broadband, so fixed broadband, essentially places where copper doesn't go or fiber can't be rolled out. Wireless is a really nice way to deliver the last mile, if you like. So putting large amounts of bandwidth into people's homes. And with 1 gigabit per second as the target within 5G, that's better than most people get over their fixed lines at the moment. And then mobile broadband, which is everything which we do at the moment, except more of it. So going from 100 megabits per second, which you might get on your phone at the moment if you're really lucky and there's a following wind and no buses going past, to 1 gigabit per second or more. And so from that came a bunch of requirements, and all these requirements fell out of a whole range of reports which started to be written in 2015. So 10 times the bandwidth per connection, that's the 1 gigabit per second challenge. Low millisecond latency. Low millisecond latency is important. AR and VR, which I'm sure you are all aware of, only work if you get overall round-trip latency below 10 milliseconds. Anything above 10 milliseconds, people start to throw up. Under 10 milliseconds, some people throw up. We had a demo that we ran with Arqiva last year in London where we were doing AR and VR headsets over a 5G or a fixed wireless access link. And quite a lot of people felt quite about having the headsets on just because of the motion sickness. You know, you're standing there and what's in front of you is a roller coaster and you're going like this, but you're still stationary. So it's essentially travel sickness. The longer latency gets, then the further out of sync your eyes are with what your brain is doing, and the worse it becomes. 5 nines reliability. 5 nines is important because that's the critical criteria for fixed line networks. So all networks are expected to deliver 5 nines availability, which essentially means you have something like 39 seconds of unplanned downtime per year within the network. Getting that with a mobile network is currently nigh on impossible. Not least because you go out of coverage and there's no network at all. So it's spatially diverse, but also the technology is air interfaces, and air interfaces don't easily support 5 nines reliability. 100% coverage is exactly what it says in the tin, coverage everywhere. Greater than 10 times the number of connections, 50 megabits per second everywhere. All of this leads you to 1,000 times the bandwidth per area. So That's a really difficult thing to measure because at the moment nobody really advertised how much bandwidth they support within the unit area anyway. 10 times battery life is about long-lived IoT. An awful lot of that long tail of the 50 billion devices that people talk about is little devices that sit in places where you don't want to send a man in a van who's going to go and read an electricity meter or test what the moisture is in the soil or make sure that your cows are grazing in the most optimal pastures. What you want is something which does that for you. But to do that, the worst thing is you don't want a bloke or a lady to go out in a van and take those measurements, so you put something there and you have to go every 3 days to recharge the batteries. That just makes no sense. So you need a really long battery life, so you put it there and forget it, and it just gives you information. To achieve that, if you think about the battery life on your phone, what your phone is doing at the moment, all the time, including Duncan's, because he's checking his, and that's very rude. Oh, that's all right. Well, we'll let him off. Okay, so what your phone is doing at the moment in a network is all the time looking to the mobile phone masts and telling them that you're there and saying, hello, hello, and making sure that it's connected to the best one, the nearest one, the one with the strongest signal. But all the time it's doing that, it's using battery. These devices now, the signaling is being optimized to the point where a device doesn't look for the nearest cell, it just appears, says, here's some data, and vanishes, under the assumption that there is a network there to collect it. But that requires that because there needs to be a network there. So you have this kind of symbiotic relationship between all of these developing. Reduction in total cost of ownership, yeah, good luck with that one. I'm from a vendor, we're going to sell some kit. So where does that take us, right? All those requirements have moved from the right-hand side of us to the left-hand side, and it's to enable all those things which were mentioned previously. So there's a whole bunch of new applications. Probably the most important one is still the one at the top. Enhanced mobile broadband is the thing that you would expect to get from a new generation on a device. When you get a mobile phone out of your pocket and it has a little set of bars and says 5G next to it, your expectation as a consumer is that 5G connection should be faster than the 4G connection that you're used to, because that's what Gs tell you, right? It is the ultimate brand and marketing exercise by operators up until this point. All these other things are new and are different, and are services and applications which people kind of feel ought to be important, but nobody has really nailed down how you put them into a specific revenue-generating use case yet. But the expectation is that by supporting a combination of these and a whole range of other things beyond, you can start to open up a whole bunch of new customer segments. All these customer segments, with the exception of the consumer, are terribly addressed at the moment. Operators sell into all of these segments, but what they sell is mobile phones and dongles. The auto industry is getting there. You might have a car now which is connected, but essentially the connection within a car at the moment is a massive mobile phone on wheels. That's all it is. It isn't doing much in the way of additional assistance towards driving. All it's doing is reporting how the car's feeling, letting you do some online services, let you have Spotify in the car rather than having to listen to the radio. So, and then beyond that, all of these things, there are niche health applications, there are niche industry 4.0 things. All of these things down here are essentially just using a data channel. There's nothing that's developed specific to the sector. The expectation is that by putting all of this in place, you can start to address some very useful things here, which are revenue generating rather than just being subscription based. So ultimately where you get to is that the MNO is looking to move out of B2C as a business model and into business to business or business to consumer. And that's through a whole bunch of technology. Now, if you're tech phobic, I'll try and go through this fairly quickly. How many people feel that they can handle acronyms? Right, the rest of you come and see me afterwards. I'll give you a paper. So I won't go into depth, but there are 6 things which are essentially there. Main technology trends that are happening. Millimeter wave. Millimeter wave allows you to go out of the existing frequency bands, which are down here, and up here. The reason why that is important, at the moment, these bands support very good coverage. In fact, the further this way you go, the bigger the cells are that you can deploy. So For example, 2G networks happen around about 900 megahertz, and there's some bits in 1800. 900 megahertz cells, you put a cell mast in one point, and it will cover anything up to about 10 kilometers, depending upon how many buildings there are in the way, how many people are connected to that cell at any one time. Further you go this way, so when you get to 3G networks primarily are around about 2.1 gigahertz. There's an inverse squares law going on, so you move 3 times the frequency this way, you need 9 times the number of cells. And cells cost a lot of money because there's physical equipment. If you think about trying to put a cell on a building in London, you need access rights to the building, you've got to run a connection to it, you've got to get power to it. All of that costs money, planning permission takes time. So you want as few cells as you can have to provide coverage. The problem is that each cell generally has the same capacity because it's in the same amount of bandwidth. And as a result, as you shrink cells, you can support more connections. So you don't want a 700 megahertz cell with 10 kilometers covering the whole of London, because there's millions and millions of people, and the most people you can connect to a 700 megahertz cell is about 200. So you've got this trade-off. As you move further this way, because the spectrum is perceived to be less useful, there are less people occupying it. So this spectrum frequency down here, not only has it got mobile networks in it, it's got radar, it's got the police, it's got a whole bunch of kind of hush-hush military stuff and secret services going on down here, and it's got everything in television and everything in radio. Some of that spectrum has been released with the move to digital TV, quite a big chunk, which is why 4G networks are quite good, because they're in the 700 megahertz chunk, which is down here, and there's more coming, so there will be a 600 megahertz spectrum release, but it's relatively small chunks. When you get up here, you've got big bands. So the target band for millimeter wave in Europe is 26 gigahertz, which actually covers 24 gigahertz to 27 gigahertz. That's 3 gigahertz of bandwidth, which is as much as is down here at the moment, covering all of those use cases. TV, police, radio, mobile networks, everything which is being deployed as a service in the mobile world at the moment is compressed into this piece of spectrum down here. You're going to get all of that spectrum, again, available to mobile networks when you get to 5G millimeter wave. So millimeter wave is important. However, as I said, big cells, smaller cells, here, tiny cells. So using the technology which you have got at the moment in 2G, 3G, 4G, up here you would get a cell of about 50 meters radius, which isn't very useful. Not only is it 50 meters radius, it's 50 meters which can't go through glass very easily, is affected by leaves on trees. You get terrible fading when a bus goes past. So it's not overly practical to deploy using existing technology. So what's been invented or reused essentially is something called beamforming. So beamforming intensifies the signal and points it in a very narrow radius, and as a result it goes a bit further. It goes anything up to 2 kilometers. So that's all of that. You're now radio engineers. You can all come and work for me. Channel coding, new channel coding, low density parity check. This helps with reliability. That's all you need to know about it. It helps you with some of the kind of cross interference between channels, which then means that you can actually do more useful things within the radio spectrum that you've got. Network slicing is a network technology, as the network bit suggests, but it essentially means that whereas at the moment you have one big network and all the customers are sitting on top of it, you can split the network up into lots of virtualized pieces. So if, as a commercial offering, if I wanted to go and sell a network proposition specifically to BMW, I could offer them complete autonomy of that network. I could give them a segment of it, they could deploy their own functions, they could bill independently, they could essentially manage the network with a great deal more flexibility than having to come through me as a mobile network operator for the every day-to-day running of the network. Massive MIMO. Massive MIMO means that you've got, on your phones at the moment, give us a phone. So on your phone at the moment, this is an iPhone, isn't it? Yeah. I won't be too upset by that then. Both buttons go forward, that's quite confusing, isn't it? Okay. I'm just trying to see if, and it's got a plastic case so you can't see the antenna. Right, so in here at the moment, there are 2 antennas, because that's a 5G thing. Right, the 2 antennas run around the outside of the device. And the reason there are two antennas is so that you can do what's called multi-input, multi-output. So one of the ways that 4G delivers more bandwidth is that you actually have two radio interfaces connected to the device simultaneously, and you multiplex between the two. When you get to 5G, you can do anything up to, well, within an antenna, so device sitting on the top of a building, you can have anything up to about 1,024 antenna components at the moment. Within a device, we do up to 64 at the moment, but that number will increase. So you can have 64 radio channels going from something on the roof down to a device, and as a result, 64 times the bandwidth. So it's one of the step changes which allows you to get into gigabit speeds. Massive connectivity we talked about to a certain extent, so the reduction of all this kind of connecting to the network down to one step up here. Grant-free access just means you don't have to do the, hello, I'm here, I'm going to send you some stuff. You're going to send me some stuff. Thank you, I've got your stuff. Right, I'm going to go away now. Thank you, you can go. That's basically how a device works at the moment. What will happen with 5G is that a device will appear, go, stuff, vanish. And then low latency, there was a couple of things that have taken place here. One is, well, it's all illustrated here, but this device, this is a MEC server, a mobile edge computing server. That can be put at the bottom of a base station. So when you're trying to do 1 millisecond delay, you run up against the speed of light and laws of physics. So the speed of light for 1 millisecond within glass is about 1,600 kilometers. You've got devices within that time as well, so they all introduce delay. You've got the device sitting on the end of the network, so the mobile device itself, that introduces delay. You want to move everything closer together. So mobile edge computing takes away some of that physical delay. The other thing which has happened is that the size of cells has been, or of data packets, datagrams, has been significantly reduced, so that you are sending small pieces of data more often to reduce the overall latency. Now, no, I'll save that for a minute. I'm going to get too negative too early. Okay. I don't want to go through this too much. This is a bit more on sort of technical detail. New air interface. This all gives you a lot more bandwidth and a reduced latency. So this is a shortened TTI, so much smaller bits of data. Flexible band sizing means you can use more bandwidth in more places. Massive MIMO we talked about, millimeter wave we talked about. CPO FDM reduces interference between bands which are close to each other with interrelated symbols. Other RAN innovations, COMP is probably the one which is most interesting and gets least publicity. What COMP allows you to do is have a device connected to multiple base stations simultaneously and multiplex traffic. So if you think about massive MIMO as being one antenna with lots and lots of radio bearers all pointing towards a mobile device, this is lots and lots of radio bearers all pointing from different directions to one device. The reason why it's important is you get more access to more bandwidth more of the time, but also all those problems that exist with millimeter wave. If a bus drives through here, you're still connected to 3 other devices, whereas at the moment, immediately you lose that signal, this device would go, help, I need to connect to something. And by the time it had found one of these 3 cells to connect to, the bus would have gone to try and connect back to this one again. You're getting into really big signaling issues. So COMP helps massively with the reliability aspect. Small cells, we've been trying to do that for years. 5G NR and unlicensed, if you're aware of 4G, LAA, it's the same thing, but for 5G. Session management split from mobility management, that allows you to have your user plane all routed very close. So that mobile edge computing server can manage all of the user traffic locally, even if the control plane disappears back elsewhere. Device to device, vehicle to X, that's essentially building localized mesh networks. The interesting thing with that is it takes the network completely out of the picture. So if you have cars communicating with each other directly, then the mobile operator isn't in that channel anymore. Very interesting commercially about how 2 cars talking to each other directly from different operators pans out when the operators are still trying to say, yeah, but we provide that service. No, you don't provide that service anymore. But we'll see how that one goes over the next 5 years or so. The not so 5G bit, which gets bundled up into it, is around topology flexibility. So a bunch of trends which have happened in the industry already. Cloud RAN is essentially lots of stuff which normally would exist next to the base station, pushed more centrally to change the economics of the network. That extends out into full virtualization, NFV and SDN, which you're currently trying to write 1,500 words on, Duncan. This is what enables you to do network slicing. Having a fully virtualized network means that all of this becomes software-based, and all of the hardware which it runs on is much more common and off the shelf, and as a result should be much cheaper. What's stopped this happening in previous generations and previous iterations of the network is that the performance of common off-the-shelf hardware hasn't been high enough. Now it's very good, so you can start to do software-based networking. This trend also has kind of pervaded into the underlying transport network. In fact, the underlying transport network has been virtualized for about 4 or 5 years. Colt do a really nice demo where they establish a 10 gigabit link between 2 data centers in 6 minutes. That's kind of cool and commercialized, so it's not just a question of somebody going out and laying a fiber really fast. That's fully commercialized with a nice point and click interface. MEC, we talked about stuff being pushed down here. Now the interesting thing is that having been able to centralize everything, there's also a trend to push everything to the network edge. And both of those need to coexist. The way that they coexist is through network slicing. Oh, hang on, I thought it was going to be a network slicing thing. It's through network slicing. Network slicing allows an architecture which is one topology, MEC-based, and an architecture which is another topology, which is cloud-based, to coexist. And all use the same RAN interface. But it becomes a bit of a nightmare when you're actually trying to manage that entire network. So why do all of this stuff? So we've seen this slide before. The reason we're doing it is because people want access to that, and I kind of hinted at that before. That's a source of revenue which is currently untapped. That's why people are going through this whole pain within network development. So the key thing with B2B and B2B to X user models and business models is that the M&O is always the first B. And the second B is all of these folks in here, all these industries which are slightly patronizingly referred to as verticals quite often. Some of these industries are bigger than the telecoms industry. They're not verticals, they're massive industries in their own right, and the reason that they haven't been tapped into with an ecosystem generating proposition until now is because they're not organized. You know, if you think about agriculture, the GSMA is a really neat organization, and 3GPP is a neat organization because you have all the stakeholders around the mobile telecoms industry gathered in one place, and it's a finite number that you can understand. Agriculture, trying to do that with farmers in the UK, can you imagine the size of the organisation? And then trying to get any agreement out of it would be apocalyptic. Healthcare is just as bad. Industry 4.0 is massive in its own right, and people just don't feel the need to organise themselves in that way, and so on through a whole bunch of others. The key thing about being the first B is that when you are the first B, your price is the second B's cost. And so the first B is permanently under price pressure from the second B because they want to pay as little as possible for the service that you're offering them. A consumer, you can justify the proposition to a consumer to a certain extent by going, here's a better service, and they'll go, great, I'll pay for that service because it's new and amazing and it feels sexy, and then I can have a new iPhone, and it's a 5G iPhone, and I can show it off to my friends, so I'll pay the premium for it. Second B's, when it's B2B, they don't care about cool and sexy, they care about bottom line. And so they will pay as little as possible to get the service that they want. Whether it's mobile network operator, Wi-Fi, anybody else, what they care about is the service good enough and is it cheap? So unless mobility is an absolute service requirement, there's an awful lot of other opportunities that will come up within this sector which won't be MNO focused. And some of you probably know Matt Hatton, who used to be at Makina Research. Yeah, they've been bought by Gartner. He's now very rich. Makina did a bunch of research a few years ago which suggested that only about 15% of the IoT opportunity is mobile network addressable. And if you go into that and you look at 2025 again at that 50 billion number, so that kind of, it's still a big chunk, right? 15%, that's still about 7.5 billion connections. If you look at 2025 5G market penetration as a whole, it's about 12% of the overall mobile network. So 5G IoT, that's not a big chunk of connections, really. So pinning a lot of hope on IoT for 5G is perhaps a little short-sighted. So now we've got a bunch of goals and a bunch of technology, And you've got to try and match the two up. So I had a stab at which of the technologies help you meet the goals and which don't. So lots of green, which is good. Lots of things are helping you meet the objectives, apart from reduction in total cost of ownership. So more bandwidth means more fibre. Massive MIMO means new antennas. Beamforming means loads of antennas. Shortened TTI, shortened TTI hasn't got anything on the red one, that's okay. Flexible band sizing, new antennas. Comp, loads of antennas and loads of fibre. Small cells, loads of small cells. 5G NR in unlicensed, loads of new cells. It's only when you get down here that you start to have a bit of help with total cost of ownership, because you've got a bit of flexibility and changes in topology. But then you're not actually helping any of the requirements be met. So the question then is, why are we doing these bits? So all of this requires massive amounts of network investment to meet. So all of these green bits is where all the red is. And then this bit, the enablers for network slicing, which is actually the key thing to allow you to get into the B2B business, is don't help you meet any of the technical requirements. So you've got a big question mark about what the heck's going on in the middle here.
Sorry, just one.
Yeah, sure.
How does I'm struggling to understand why the cloud RAN and the virtualization doesn't have the latency. Isn't that part of the argument?
No, because so what you're doing with cloud RAN and NFV is moving things further away from the antenna. So you don't know where the network functions are anymore. I do about round-trip network latency. So the really interesting thing, and one of the things that I put in the GSMA paper in 2014 is the reason that people hadn't done cloud RAN before was because the performance of common off-the-shelf servers wasn't high enough. So immediately you get to the point where it just about meets the requirements according to a hardware integrated solution, you then make it more difficult by separating the hardware and the software and having an interface there, which increases the latency again. The best way to build a low millisecond latency network is to have a fully integrated network where the hardware and software is fully integrated together and the synchronicity between the two is minimized. So if you wanted to do really low millisecond latency, you fully integrate everything, you ignore cloud RAN and virtualization. And I think the best illustration of that is that there's been a lot of networks put up which are fixed wireless networks between financial centres. Like, I think Deutsche Bank did it first between Frankfurt and London, on the basis that having very small marginal millisecond gains as a result of the speed of light over air being quicker than the speed of light over fibre gave them trading advantages. Immediately they did it, there are now about 50 networks independently run between London and Frankfurt, between the two stock exchanges and trading floors, because it became such a competitive advantage. All of them are done via integrated network solutions, and I don't think you'll ever see them virtualized because it will slow things down again. Whereas MEC allows you to push everything to the edge of the network, but once you push everything to the edge of the network, you have to buy a load of MEC servers. Yeah, so instead of having here 15 data centers and a load of servers, here you need 30,000 servers because you need one per antenna, or 7,000 maybe if you do one per 4 basis.
The first view of that sort of says, well, why are we bothering with cloud RAN? Because there is a huge Xbox in it.
I'll explain to you. I'm glad you asked me that question. We're going to massively overrun. Right. Network slicing is why we're doing it, so network slicing allows you to get into that B2B business model, right? The one which everybody's trying to unhook, because everybody uses BMW as an example for this reason, because they're big and they're quite tech savvy. The other reason is that they bought a billing system about 5 years ago because they thought that they were going to be able to set up a BMW mobile virtual network operator across all the operators in Europe, and they would own all of the connections to their cars and they would manage it all. The mobile operator saw that coming and basically didn't agree any commercial terms with them. But if you're going in the direction of network slicing, then that actually could become a reality. You could have BMW having a fully virtualized network instance across all operators in Europe. And it would be very difficult to stop, because if you didn't let them do it but you were selling it elsewhere, you'd run into all kinds of commission, non-discriminatory terms. mobile virtual networks and virtual networks in general have this layer across the top called orchestration. Orchestration is what allows you to provision the network with a service or provision the network with a virtual network function. It's kind of like the existing network management system on steroids because it's doing a lot more things, probably integrates a bit of billing as well, but you have many different points of orchestration. So you have a RAN orchestration, which is all the purple bit, a core network orchestration, which is over here, and your transport network, which has to be orchestrated as well. And sitting above that is an end-to-end orchestration layer, which is where all your applications sit. So if, for example, BMW decide that they want to put a new service into all of their cars, they define the application up here, and then it filters down to be orchestrated through all of these functions and on the application that sits on the top. So that's one service in one operator, or sorry, in one commercial partner, which could pervade into all operators. So you can see how it becomes quite complex quite quickly. The trouble is, on this side, this is BMW in that example, so they are then trying to control all the applications. So the application down here, which you're orchestrating, needs to come up and be permeated into here. They have their own virtual network functions. They might have virtualized CPE. They've got a data center, which is where all this stuff is running from. And they need to have all of what's going on here combined back together to be presented to them as a customer, which is network splicing. That's trademarked, by the way. If you use it, I will chase you. And the reality of that is that actually you're going to have lots and lots of slices per enterprise customer, and they may have many requirements. So BMW won't turn up at a mobile operator and go, I would like you to deploy all of our cars with Spotify across all of your network. They will turn up and go, we've got this set of 100 applications that we want into the car, which covers emergency calling, covers the management of the in-car systems, it covers media, it covers a whole bunch of things, plus we'd like you to connect up all of our sales staff who've got devices in their bags. We'd like you to connect up all of our offices, and we'd like that to work across all networks, whether they're mobile, Wi-Fi, 4G, 5G, whatever. So actually what you end up with is the requirement to support many, many slices to make one customer proposition. So you have one or more 5G slices per enterprise customer, plus an inter-orchestration system interface, which nobody knows how that works at the moment. The great thing with open standards is they're so open that they can be anything, and indeed many open standards end up being proprietary. But then you've also got your 2G, 3G, 4G network, which could be sliced now, because that isn't really a 5G thing. That's why it said not so 5G. There are virtualized 4G networks out there. There are certainly virtualized Wi-Fi networks out there. There are definitely virtualized fixed line networks. If you're combining all these together over here to an enterprise customer, that's an awful lot of slicing. The orchestration layer becomes very, very complex because you're trying to make all this work in synchronization. The network splicing orchestration becomes very complex as well on the other side of the interface. That inter-orchestration system interface, like I say, nobody knows what that is at the moment, and it's many, many different things to many different people. And then down here, this is the radio management layer. So at some point, all of this traffic ends up at a base station and has to be prioritized and made sure that it meets all of the SLAs. So that 1 millisecond round trip delay thing, if you have loads and loads of devices sitting here all demanding 1 millisecond delay, something has to give, unless you've really thought about how your network is engineered. And all the evidence that we see suggests that nobody is thinking about that. So you end up with this kind of slicing nightmare. I was at a conference in Lisbon in November, I guess, and I asked the question of the audience, how many slices do you think will exist in a network? The range of answers was from 6 to millions. So that gives you an idea of where people are thinking and the breadth of it. I think the millions side is much more close to reality. If it is millions, it's going to be a massive problem because of this. So you slice on the basis of topology. So you need to have your MEC network coexisting with your cloud RAN network, which are essentially doing the same thing. You might need a comp slice. You might need a slice for a building, a small cell slice, an unlicensed slice. All of these things have to exist in different topologies because they're all implemented in different ways. And you can't have a device attaching to a network with a specific SLA that it requires for a specific application and being applied to the wrong network topology because it all breaks. So you have to have slicing end-to-end understood to make all of those different SLAs and different network topologies work. But then you have BMW turn up and say, well, we'd like a slice of your network for all of these reasons. We want a bit of everything. Can we have a virtualized slice as well? Toyota then turn up and say, we'd like that too, but we don't want to be on BMW slice. We want to be logically separate because we don't want information crossing between the two. So every enterprise customer in that B2B or B2B2C model, they might want their own slice too. And this is so easy now to become an MVNO. There'll be MVNOs who will turn up and say, well, we want a slice. You know, why is Tesco Mobile sitting on Vodafone's network without all of this autonomy which you're giving to customers? We want a slice as well, and we'll manage our own network implementation. And that's what MVNOs have been asking for 20 years. So MVNOs, unfortunately, they have enterprise customers who are going to want this too. So you end up with slices of slices of slices. And the maths of that, you know, let's say 5 MVNOs in a mobile operator with 10 enterprise customers who want 5 different services. That's 2,500 slices before you've even got to go, or 250, sorry, but you can see how it multiplies up, right? So at some point, all of that has to come back together and be stitched together in network splicing, which is going to be an art form. And then this is the biggest problem, I think, because you've now got a network which is very complex, very difficult to manage, and what you're trying to sell is a whole bunch of SLAs which you've never had to deliver before. And the problem is that, yes, all of these things perhaps allow you to address this, and that means big contracts. So the good thing about BMW, I turn up at Vodafone and say, can I have a network connection? They go, absolutely, sir, that will be £25 a month. BMW turn up, they want 100,000 in the next 6 months. So it's big contracts, lots of money, addressing all of these untapped markets, new revenue streams, a whole range of things that can be delivered. The problem is that my service, for my £25, I get my phone out and I try and ring my wife, and it doesn't work. I go, oh, bloody mobile networks. And I lean out of a window, or I move outside of a building and I press the green button again. These guys won't accept that. If you've told them they've got 5 nines reliability and 100% coverage, they want 5 nines reliability and 100% coverage. So your network had better do it, because if it doesn't, there will be things in their contract which say, if you're not meeting the SLA, you pay us penalties. And this is where my 2 years at Capita came in, because Capita were being burned through their backside by all of these kind of things. And if you look at the Capita share price over the last 4 weeks, you can see how that's reflected. So of that list of requirements, these ones over here, they are contractual obligations. And the interesting thing about these is, these are not technical problems. Yeah, I can't invent a technology that does 5 nines reliability. To do 5 nines reliability, you have to build a network which has full redundancy in fiber, full redundancy in equipment. You basically have to deploy 2 of everything everywhere in case one of them breaks. And that's not how networks get built at the moment. And 100% coverage means you cover 100% of the country. I was on a panel with, well, it was EE, I won't name the specific person, but it was with EE, who have the Emergency Services Network contract in the UK, which has in it a universal service requirement. So the ESN network means that at the moment all the radios that the police and the ambulance services and fire service use are on a technology called Tetra. There is a Tetra network which is being built and is implemented. That's all going to be replaced by 4G, by voice over LTE for voice and by LTE data. Voice over LTE, that's slightly worrying because I might have written that. I hope it's okay. But the 100% coverage requirement, I was on a panel with a guy from EE who said, it says 100% coverage, but actually what that just means is roads and rail network. Because it's British Transport Police and the police and ambulances and fire engines. And I did make the point that the problem with being a policeman is that people don't bury dead bodies on roads and railway lines. They take them into fields or into woods, and then they bury them. So if you're the poor bloke or lady who finds the dead body that's been decomposing for 4 months in the ground, you need to tell someone straight away. And so it actually does mean you have to cover the places where no one goes, because that's where bad people do bad things. So all these requirements are actually going to turn into contractual obligations, and they're going to have penalties associated with them. And then you get to this. So of that list of requirements, this lovely pinwheel is from an ITU document, which is the basis of which technologies which are pseudo 5G, IMT 2020, will be assessed. And the important thing is 5 nines and 100% coverage aren't here. And the reason they're not on this pinwheel is because the ITU knows that they cannot technically assess that. They are commercial decisions. They are not technology requirements. You can build a network which meets all of this with one cell in the middle of London and call it 5G, but it won't meet 5 nines availability and it won't be 100% coverage because it'll only be in one place. I'll leave you to read this piece of text, what they define ubiquitous as, because what they define it as, it's 100% coverage, ubiquitous coverage, everywhere where the network is. So the places where the network isn't, then you might not get ubiquitous coverage, shockingly enough. So, we got to conclusions quite quickly. So there's a lot of hype, right? There's a whole bunch of stuff around 5G which is hype generating. The problem with a lot of this is that the technology doesn't meet the hype. The technology isn't the key factor here. So when you're at Mobile World Congress, you lucky people, I will be there too. We will hear an awful lot of people talk about where they are on their 5G roadmap. There will be vendors, probably us as well. There's a big thing called the Winter Olympics, which we're kind of involved in, talking about how great their 5G networks are. The bits which are dodgy, 5 nines availability and 100% coverage. But there are other bits as well, which, whilst the technology takes you a certain distance, they're not actually going to be addressed without an awful lot of investment by mobile network operators. And I think this is why we see this kind of split between what's happening in the Far East, where people are much more on the page of technology for the sake of it, rapid deployment, and what's happening in Europe. In Europe, at the moment, operators are skinny on margin and they don't have lots of money to invest. And as a result, we're going to see a real lag on 5G networks in Europe. We might see some things which are called 5G or 5G ready or 5G like, but the chances of them actually being 5G according to the technical standards is pretty slim. So you end up in this weird situation of needing to have a kind of another layer down to really be able to ask the pertinent questions. Now, the interesting thing from your perspective, there are some analysts, journalists out there who will meet with your clients, and you'll be sitting there doing what you do, making sure nobody says anything stupid and taking lots of notes, so that if somebody does say something stupid, you can point at them and go, he said it. Some of the journalists know this. When the camera's off, I'll tell you who. And some of them are asking questions about this, and some of them are becoming quite pushy about it because, they've had enough. They've had enough of people spinning yarns. It's been going on for 3 years, and now they're at the stage of going, come on, this isn't actually going to happen, is it? We're not going to see 100% coverage because 100% coverage is really challenging. So what are you going to deliver, and when are you going to deliver it, and which of the technologies are you actually going to implement, and how can you not turn red in the face when you call that 5G when really it's just 4G with a fancy coat on? So all of this is going to happen. The first launches are likely to be fixed wireless, which is interesting itself. So not mobile, which if it's a 5G mobile service, but it's fixed wireless, it's kind of cutting the cake in two directions at the same time. I'm not going to go too far because a lot of them are built on Samsung. So Verizon's fixed wireless access service, which they're going to launch this year, is Samsung and Ericsson kit, but it is labelled as 5G fixed wireless. So I'll kind of let them off. And device availability, this is going to take ages. So I've seen lots of people talking about having networks launched in 2018. AT&T were pushed quite hard on this last week. They said, yeah, we're going to have something 5G 2018. What devices are you going to? Oh, we won't have devices. What use is that network? Certainly won't be supporting the millions of connections per kilometre squared. So I think that might be it. Oh, yes. So final word goes to Wikipedia. So the Wikipedia 5G page has this quote: need to clarify, clearly differentiate between content about the IMT 2020 standard itself, pre-5G LTE Advanced Pro, blah, 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 blah. the page, the Wikipedia page is a mess. It kind of jumps around all over the place. I think it is a very good metaphor for where we are in the industry at the moment. The industry jumps around all over the place when it talks about 5G. It doesn't really know what it means by 5G, despite this having been a topic for about 3 years. And every year, I know that Mobile World Live produces a parody video of what is 5G, and all of these bits and pieces spliced together about people saying what they think it is and then people challenging them and the answer being something different. I know because I've been included in it. Nothing has changed this year. So we'll hear loads of stuff about 5G at Mobile World Congress. Take it all with a pinch of salt, bring it all back in-house and work out what you want to do about it, because it is your clients that are going to be doing some of the talking. Is also people that you interact with regularly who are going to be asking a lot of the questions. So having just that little bit more insight, one of the things that we used to do, going right back to the beginning when I was I was at GSMA and you were acting as our PR agency, one of the things that we always used to make good ground out of was being able to provide that next level of insight, to be able to say, yeah, this is what you're hearing, but actually it's more like this. And that's why we used to get quite a lot of interviews and get to talk a lot. And that's why I'm standing here today. And in that situation, I think we ought to have questions and sandwiches.